afternoon, everyone. Sorry, occupied by something else. All right. So today we will start our. We will for today class. We will continue the tutorial. So I believe previously we stopped at around a moment. Tutorial 6, questions number 2. We should start at question 2. Okay. So since we have plenty of time, so I believe for each and every questions, I will ask you all to share your screen if applicable. Else, you can put it in the chat box. Yeah. Then I will share my answer after that. So we will start by tutorial 6, question 2. I hope you all with me. Okay, so for question 2, briefly describe operations A, shows in figure 2, state also the application of this operation in morphological image processing. Okay, I believe you all are quite well versed in terms of morphological operations since you all just submitted the assignment. So let me call upon the lucky one. Wing Liang Yo Wing Liang. Can you share your screen on this answer? I think this one, let me check. Oh, this one you may not need to share your screen. Maybe you can put answer in the chat box also, okay? Are you there, Wing Liang? I got a question about drawing. So I got, oh yeah, of course you can share your screen, up to you. You may share whenever you're ready. I think for today class and also the Thursday class, we will have it online. Those face-to-face students, maybe you need to take notes. I will ask GA to send a reminder for you all again, because I'm currently close contact with COVID positive patients. So so far I'm fine. That's the negative. So anyhow, I think best is not to avoid face-to-face lah. If since you're all going to examination, sit for examination soon, so best not to trigger any unwanted plots over there. Do we need to draw? You mean for these questions? Let me think. Let me see. No, I think this one is okay, because the question is asking for briefly describe the operation A. Is they asking you to draw? So but of course, if it, sorry, not to complete my sentence. I'll complete. Okay. Um. For this kind of question, sometimes no, especially in examination, because soon you're all going to sit for examination, right? So for my paper, if you think you can explain better by a drawing, it's okay for you to draw. I don't mind that. Okay, so something like that lah. For example, if the question did not ask you to draw, but you think you explain better by using any graphic or diagram, you can include. Okay, because sometimes I do agree that if you put it, draft something else, for example, a simple graph or whatsoever graphic to illustrate your, the point that you want to bring out, and then you put it in bullet point to explain further. I think that is okay as well. Okay, because uh, in final examinations, although there is a answer scheme, a marking scheme, but nonetheless, if the explanation is more or less related or maybe match to the answer, then it's okay. Okay. But of course, you must have your key point over there. Okay. If let's say you want to, the answer is opening, for example, morphological opening, right? The answer is opening. So but you did not mention the word opening. You mentioned what is the operation inside morphological opening, you may not get the full marks, something like that. But nonetheless, if you mention the I mean erosion first followed by dilation, then that is the content of opening as well. But nonetheless, if you miss out the key point, perhaps you may not get the full marks. But I will not give you a zero mark for that one. Okay. Okay, let me check the answer. The dilation is a process. I hope I did answer your question, Wei Hong. Wei Hong, sorry. Okay, let me check the answer. Dilation is a process where it expands the foreground. It adds pixels. Oh, okay. But nonetheless, for this kind of question, always remember to identify. I believe not only answer, for MTA alone, for the rest of the paper, it's important for you to identify. Because for now, the question is asking operation A, right? Perhaps you should start your answer with operation A is what? Okay, I know I know you meant the operation A is dilations, okay, but nonetheless, you did not mention that operation A is dilation, okay. So it's good for you to start the answer with operation A is dilations, and then followed by dilation is a process where da 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 da. Okay. Application used to fill in small spurious hole, such as pepper noise, smooth da, da, and edge detection. Da, da, da. Okay. Thank you for your answer. Let me share my screen. So do we need to draw the zero padding for the I wrote okay. For this one, I think I did answer these questions. Someone from physical class asked the same thing. Okay. In your final examination, it's all. I mean, if let's say these kind of questions, as per what Wei Hong asked, is appear. So you can either draw or don't draw. Okay, up to you. Because the reason is that some reference book they will include the zero padding. For example, now it is a 3x3 the original image is 3x3 pixel block. Okay, so after you apply another 3x3 structure element, so basically you would expect to have another, another line of boundary, right? But in MATLAB or in other practical software, basically after you perform any filtering or whatsoever, your input image and the output image would be the same in dimensions. For example, you have 300 times 300. After you perform the whatsoever dilation or any morphological operations, after apply that one, after apply these operations, your dimension of the input image remain unchanged, which means it is still 300 times 300. So if in examinations, you want to draw or don't draw, is okay for me. Okay, I will accept both the answer because in practical, you don't, in practical, it will not increase the zero padding will not increase your output image. The size of the output image is not logic. Okay, but nonetheless, zero padding would be performed in order to allow the structure element to be applied. But in some reference book, in the output image, there will include the zero padding. Okay, so yeah, it's based on you lah. Okay, but nonetheless, if the question did ask use zero padding, so I would suggest you all to draw. Again, if the question asks use zero padding or whatever padding, maybe reflection or whatever padding, I would suggest you all to draw. Okay, but it's good for you to remark this one in your examinations. Let's say zero padding is used in order for the structure element to apply something like that. Okay, just FYI. All right, so let me share the screen. Okay, so this is the questions. Very obvious that you have a smaller region, and then after apply operation A, you get a larger regions. So this is the structure element. So the operation called dilation. Okay, the first thing is to define the first thing is to define what is operation A. Okay, Operation A, I mean, the operation is called dilation. The definition would be expand the foreground. So basic effect of the operator on binary image is gradually enlarge the boundary of regions of foreground pixel. Thus, area of foreground pixel grows in size while holes within those become smaller. Okay, so those are many. There are many specialists used for dilations. For instance, it can be used to fill in small spurious hole, which is the pepper noise in image. Dilation can also be used for edge detection by taking the dilations of an image and then subtract away the original image, thus the highlighting just those new pixels at the edge of the object that will be added by dilation. Okay, so this is the answer for the question two. Uh, Actually, I would not suggest you all to memorize it because sometimes the wording or the sentences from um, any reference book or the lecture notes may not be that easy for you to remember. So the best is to how to use. I mean, how actually dilation is being applied. So you just write whatever you know in your final examination. But nonetheless, uh, make sure your grammar, your English is readable. Okay, if your English is not readable, it's very difficult for me to comprehend. Okay. Um. Okay. The next questions. Next question. Using figure 3 below, describe a term fit and hit of the basic operation in binary morphological operations such as erosion. Okay, so this is to describe what is erosions by using this one. Okay, so uh, yeah, but sometimes for this kind of question, depends on the marks given. You can actually draw the output of this one. Okay, if the marks given is like 10 marks, then perhaps you need to draw. If maybe just 3 marks, then you don't need to draw. Instead, you need to explain what the erosion going to do and what would be the expected output, something like that. Okay, so let me unshare my screen. Brenda, could you mind to share your answer? I will try to release your, okay, you may share your screen or put it in the chat box. Thank you. I would release your lab report and also assignment perhaps by this week. I think maybe by tomorrow or Thursday. Then you all can check your own assignment and lab report. And if you have doubts, you can email me individually. Okay, directly email me if you have doubts. Okay, the marks would be given. I mean, would be in your lab or assignment lah. Okay, so check on the marks. And then if you have doubts, you return to me. I mean, by this week lah, this Friday. Okay, because I need to key the marks by maybe next Monday. Okay, so I try my best to release by tomorrow lah. Okay, erosion is meant to shrink the foreground. The erosion process starts with superimpose the structuring element on top of the input image so that original of the SE called inside with the input if the corresponding underneath okay. Okay. Um yeah, remember that in your examination, if you want to use abbreviation, make sure you define first. Okay, for example, SE, make sure you put structure element or structuring element and then bracket SE first. Okay, do not just use the SE as it is. Okay, let me share my screen. Okay, the structure element is said to, thank you, Brenda, for your answer, is correct. The structure element is said to fit the image if for each of its pixel is set to 1 and the corresponding image pixel is also 1. Okay, I think I did include the explanations in the lecture notes as well. So fit and sheet is a very important and fundamental uh, principle in terms of morphological operations. So it's very important for you to know. So similarly, a structured element is said to hit or intersect an image if at least for one of its pixels set to one corresponding to different pixel is also one. Okay, actually you can draw lah, but of course if you include any drawing, if you include any drawing in your examination, make sure you explain a bit lah. Okay, don't just put the drawing over there. Exception is for those questions that ask you to draw. For example, if the question given this and maybe this structure element and ask you to draw the output, then you don't need to explain it. Okay. But if the question asks you, I mean, if the question like this one just asks you to describe, but then instead you want to draw something else, make sure you explain. Okay. And yeah, always answer according to the marks. If the marks given is not so high, don't spend your time on that questions to expect a lot. In fact, only 1 or 2 marks. Okay, know how to earn your marks. So this is basic principle fitting and hit. So fitting, which means the entire structure element is being fit inside the foreground. Okay, and hitting is just part of it, touch or intersect with the foreground. Okay, so I think you all already know this very well. Okay, the next question, elaborate the effect of erosion and dilation to the input image in morphological image processing. Okay, this question I think you all are quite well versed again because of the assignment. Isidro, would you mind to share your answer? I think you don't need to share screen, right? You can put it in the chat box. Are you there, Isidro? Oh, okay, good. You may put in the chat box whenever you're ready. One moment. I have launched a pool. Help me to do the, help me to do the, uh, I mean, complete the pool. The question is very simple. Is that the assignment difficulties? 5 is very hard. Don't everyone vote for 3? Yeah, please. End up, I do not have any feedback. I wish to get the feedback from you all. Is the assignment question is very easy or very hard? So 5 is very easy. 1 is very, sorry, 5 is very hard. 1 is very easy. Help me to complete the pool. Thank you. I will launch another one for lab. Let me continue for this one. Yes, okay. Dilation add pixels to the boundaries of object in an image, while erosion remove pixel on object boundary. The number of pixels added or removed from the object in an image depends on the size and the structure. Okay, good. Thank you for your answer. So let me share my screen. Okay, the erosion of a binary image f by the structure element s denotes f minus s. Okay, this symbol. Okay, produce a new binary image which is g. You can actually use some other variable is fine, but nonetheless, the most common variable for f, s, and g. I mean, this is the most common variable that we usually use. G is the output, F is the input and S is the structure element. Okay. Nonetheless, when you all if you all going to use this one is fine, because it's very common. Okay, but if you keen to use some other symbol, make sure you define what is it. Okay, for example, you don't want to use F, you want to P, you don't want to use S, you want to use E, please define the symbol. Okay, we want of all the location X, Y, and the structure element origin at which the structure element S fits the input image. So that is, IE is, that is a, so G is the output, is equal to 1, and S fits uh, F, which is the structure element fits the input image, and zeros for otherwise. So repeat for all pixel coordinate xy. Erosion is meant to shrink the foreground. So the dilation of an image F by a structure element S denotes F plus S produce a new binary image of this one. Okay, basically just as add on the G. Okay, with one in all location xy of the structure element origin at which the structure element hits, S hit the input image. So again, is whenever you hit, then you want the rest. Otherwise, will be zero. And repeat for all the x and y's coordinate. So dilation has the opposite effect of to erosion. It adds a layer of pixel to both the inner and outer boundary of region. So dilation is meant to expand the foreground. Okay, so it is very simple, and yeah, even though dilation and erosion is very simple, when you have different, very weird structure element, it can be challenging. So make sure the fundamental is solid. You really know how to use the dilation and erosion, not just in MATLAB, but to explain and also to do it. Uh, I mean, to draw it out whenever given structure element, and try to practice yourself with different kind of structure element. Okay, not only this one. This is a very cliche patterns of the structure element. Okay, maybe you can try to practice with some others to test your knowledge lah. Okay, so that's all for the tutorial 6. Do you have any questions? No? Okay, good. If you have questions, feel free to ask. So let's move to tutorial 7. Tutorial 7. This is tutorial 6. Actually, tutorial 7, no, should be tutorial 9 and 8. Sorry, 8 and 9. Some question need to be dropped. Okay, so for tutorial 7, and now we move to calculations, which is in audio. If a set of ear protector reduce noise level by 30 dB, how much do they reduce the intensity in power? Okay, I believe in NTA, we do not have a lot of calculations, but in terms of audio processing, we have calculations. For compression, I don't think we have calculation, but for audio processing, which is chapter 8, I think, 8, 9, 10, yeah, chapter 8, I think we have calculations, and also the initial chapter, which include the calculation of size, the memory, then that one would include the calculations. Okay, I think the calculation won't be too burden for you all. Um, uh, yeah, I think you all can score in the calculation. Should be no issue. Okay, let me get someone. Perhaps this one you need to share your screen because I want to see the solutions, not just the final answer. Liang Hong, maybe you can share your screen or answer. Let me unshare my screen first. Liang Hong, are you there? Okay, I have launched another poll, which is for lab report. Help me to vote as well. Thank you. Okay, Lok Jing Yao, are you there? Can you share your answer for tutorial 7, question 1? Lok Jing also not here. Wei Hong Ng. Okay, good. Oh, just now you raised the question, right? Okay. Yeah, would you mind to share your answer? Thank you. Would you mind to zoom in? Okay. One moment, let me grab the answer for question one. So I is when I equals to P divided by A, I will be reduced as in proportion to I. Okay. So your I answer is 1 like multiplied by 10 power of negative 9, is it? Yeah, it's okay. I just trying to get, to check which one is your answer. Okay, thank you for your answer. Let me share my screen. Again, because you all are quite, sometimes did not write anything using your hand, but not the computer. Make sure you all can write well, okay, and write fast enough. Okay, because I believe when you were too long, I mean, not using the pen to write something, not virtually but physically, you may very slow in writing. Okay, try to. I'm not sure what would be the possible way for you to practice, but yeah, try to brush up your writing skill. Make sure the writing is readable. Okay, basically the answer is correct lah. Thank you, your answer. So if a set of ear protector reduce noise level by 30 dB, how much do they reduce the intensity in power? Okay, so this, first of all, you need to identify the correct equation. Okay, and remember in MTA, we do not provide you any equations, any formula, because the formula is very minimal. So we do not provide you any equations. Okay, don't expect you can find and maybe formula sheet in your examination paper. None of it. So sound intensity will be 10 log base of 10. So P divided by PO. P is the intensity. PO is the threshold of hearing. This can be found in the lecture notes. Okay. So since threshold of hearing is this one, okay, given in the lecture notes. So then you just write down the equations. So 30 is equivalent to the formula, and then you put in everything and you rearrange to get the P, resolve it to get the P. So basically this is the P value. And then again, remember the correct SI unit. Okay, if without the SI unit, I will not give the marks for the final marks. Of course, you will get the marks for the solutions, but you will not get the marks for the final answer, which is, I think, mostly 1 marks. Okay, please do not think that the final answer is the something very, very is important, but not the most important one. So if you without the solutions, just give me the final answer. Usually you have a very minimum marks, even though your final answer is correct. Okay. So remember, without the SI unit in engineering is very big problems. So make sure you include the SI unit. And yeah, your answer is correct. Reduced by 1 multiplied by 10 power of negative 9. W divided by m squared. Okay. That is because they follow this one. Okay, the second one, state the Nyquist frequency for the following digital sample interval. So you have ABC, AB lah, 2 lah, okay? Maybe anyone can share the answer for both of it. Let me unshare my screen. Chua Yu Yang. Let me check the pool. Yeah, you may share your screen whenever you're ready. I believe this one you need to share your screen because about calculations. Okay. Um, one moment. 20 kilohertz and 1 kilohertz, is it? Yes. Okay. One moment. Please do not unshare first. 20 and 1. How you get 20 and 1? 1 divided by T, 50 micro. Oh, 20 kilohertz. Okay, sorry. 20 kilohertz and 1 kilohertz. Okay. Partially correct. Okay, you may unshare your answer. Thank you. You are partially correct because you yet to complete the answer lah. Okay. One moment, let me check on the pool first. So assignment is not very hard. Majority work for moderate. And 5 work for quite easy. Lab report 1055. Can I ask someone to voice out? Do you think the assignment is really difficult, sir? I think assignment question, you have two questions, right? Question one and question two. Question one, actually the whole question is about image enhancement, salt and pepper noise, and also the Gaussians. And for question two is more on to get whatever intended answer. I think most of you can do quite well. And for the lab report, 10-7. Okay. Anyone think that the lab reports is harder than assignment? Because I saw one word for very hard for lab report. Any comments from you all? Do you think the lab report is harder than the assignment? Basically, your assignment, I mean, most of you, the assignment answer is shorter than the lab report, actually. Okay, so back to the questions. We have 50 microsecond. So state the Nyquist theorems for the following digital sample interval. So this is actually the digital sample interval. So when you have sampling, so we use the variable fs. But fs is the sampling for this one I mean in terms of Nyquist theorem. Do not forget Nyquist theorem is the I mean you need to get at least 2 times the frequency that you have it, and then that is the sampling interval. Okay, if for example you have maybe 1K, so you need to 2 multiplied by 1K frequency, so that your sampling frequency should be 2K, something like that. Okay, this is provided you don't have any upper and lower limit. If you have any upper and lower limit, so 2 multiply by your upper limit minus by lower limit and multiply by 2. So this is it. Okay, so fs, so since the interval is 50 microsecond, so you have this formula in order to get the fs, but the value provided here is the fs, but you need to know the value of fm. Okay. Nyquist frequency okay, so 2000 equals to 2 and divide by the 2 so you will get this one. Okay, this is the sampling frequency. And the another one is like this one, I mean 0.001 second. So you have 0.001 second. First of all, calculate the sampling. This is the sampling interval. So 1 divided by this one, you will get your 1K, which is provided as per Yu Yang. And then 2 multiply, I mean, put it into this formula and get your FM, which is 500 Hertz. Okay. The next questions, compute the memory required in kilobits to store 35 minutes of the digitized audio uncompressed by assuming the standard sampling rate of CD-ROM for mono and also stereo. Okay. For this one, I need someone to share the screen as well. Boon Kyung Koo, would you mind to share your screen? Or for this question, which is question 3. Question 3 in tutorial 7. A and B lah, both lah, because the formula is the same. Boon Kyung, are you there? Okay, how about Chun Wei? Chun Wei Lim? How about Han Xiang Ng? Okay, good. Have you done this? Maybe you can share your screen. Wow, okay. Give me a moment to digest your answer. Holy four. Multiplied by 60, multiplied by 35, multiplied by 60, divided by 8. Divide by 8. Do we need to divide by 8? When you divide by 8, you are converting to byte, you know. Yeah, because you have 16-bit, right? If you divide by 8, you are converting to byte, and then divide by 1024 is converting to different, maybe kilobyte, and so on and so forth. So, yes, perhaps you don't need to divide by 8, because the answer is asking for kilobits, not kilobytes. Okay, so do not lose your answer. I do not lose your mark by some of the minor mistake lah. But of course, even though I know you understand the answer, but if you give this wrong answer, then should be wrong lah. Okay, but of course I will allocate marks for whatever you have which is correct. Okay, and one moment, let me check the other one. 44, 16 times 2. Okay. For the first one, I would suggest you to put in times 1 because it is mono, right? But it's best for you to put in multiply by 1. Okay. Thank you for your answer. Let me share my screen. Okay, so compute the memory required is in kilobit, so you don't need to divide by 8 to store 35 minutes CD-ROM. Okay, so the sampling rate, which is 2 multiplied by upper limit of human ear, and the for CD-ROM is 16-bit lah. Okay, so convert the bit to gigabit. So you can divide by 2 power of 30 lah. Okay, this is 2 power of 30 is just to convert to gigabits. Okay, not converting anything else. So if you want to convert bit to byte, you need to divide by 8. But since the question is not asking for byte, so you don't need to divide by 8 lah. Okay, so memory required, which is this is the very common equations to calculate the memory. Sampling rate, the number of channel, and also durations. Of course, from time to time, for different types of calculations, you might have the items required inside this calculation, this equation would be more or less the same. But sometimes, if let's say you are calculating mono or mono audio or stereo audio, you might have include this one. If not, for example, in to play a video and then the video with how many frames, it is actually more or less the same equations. Okay, so look into this one. You have 35 minutes. Always remember, we need to convert it to second. Okay, so sampling rate, which is 44.1 kilohertz. Yeah, 44.1 kilohertz multiplied by 16 bit and multiplied by 1, which is mono, and 35 minutes multiplied by 60 seconds. And just meant to divide by 2 power of 30 because I want to convert it to gigabit. Okay, so you will get this one and you get this one. Okay, it's equivalent. But this one is divided by 8. If not, but I think the answer should end here. Okay. Um, but in fact, I think the answer should be in kilobits instead of GB lah. Okay, because the question asked in kilobits, right? Okay, so maybe you do not need to divide by 2 power 30. Instead, you divide by you convert it to become uh, in kilobits SI unit. Okay, the same goes to here, stereo. Sampling rate, number of channel, duration, everything remain unchanged except for one you change to 2 because you have stereo. Okay, and again, this one divided by 2 power 30, so you get GB, but in fact, you may convert to kilobits. Okay, so thank you. The answer from, oh, Anxiang. So let me start presenting. One moment, let me open back the tutorial first. Questions, tutorial 7. Okay, so we have question 4. Define the signal to quantization noise ratio. This is very, very easy. SQNR, anyone? Um, Nailing on, are you there? Maybe you can share your answer. I think this one is okay to share in the chat box. You can just put it in the chat box. Okay, some of these common definition, perhaps you all need to know. Okay, for example, what is signal to noise ratio, signal to quantization noise ratio, what are the basic elements of multimedia, what is some of the very, very basic. So, yeah, maybe you need to know some of it. Okay, a signal to quantization noise ratio that characterizes the quality of the quantizations is widely used is widely used quality measure in analyzing digitizing schemes such as PCM. Okay, so quantization noise is defined as this one. Quantization noise is defined as the difference between the value of the analog signal for the particular sampling time and the nearest quantization interval value. Okay, um, just to further explain, for this one it is actually referring to the gap. So it is actually referring to the gap when you have an analog signal. So when you convert it to become, I mean, sampling it, I would say, sampling it. So all the noise, quantization noise would be those that happen over here at this gap region. Okay. Because it's impossible you will get a purely, I mean, because you are converting something from continuous to discrete. So for sure, when you convert, I mean, perform the sampling, you will not able to get the um, exact patterns over there. You are just estimating the origin, I mean, the analog input wave. So these are the gap that are missing, where all the information encrypted in this region would be missing. Okay, nonetheless, this quantization noise would not be so significant lah. But if in case it is very significant, it will affect your, I mean, it will introduce artifacts in your audio file. Okay, but nonetheless, this is not the major noise that would appear in your audio file. That is because the this kind of signal to noise ratio only happen at the this region. Okay, the rest of this region unaffected. Okay, so this is the SQN. Okay, so for question B, if 8-bit linear quantization is used, determine the largest quantization error if the signal is in the range of -5 volts to 5 volts. Okay, so this one I might need someone to share their screen. Let me stop sharing. Xue Pang, are you there? Maybe you can share your answer. Okay, you may share whenever you're ready. Um, is this the answer for B? 6.02 multiplied by 8 equals to 48 something. Is this for B or C? I'm asking for questions for B. Sherwin? Perhaps. Because the question you're asking, you have 8-bit. Oh, I know why you multiply. Okay. Usually, the question given, all the numbers or value given in the question usually is required for calculations. Okay, so if you only use part of it, rethink and rethink, either it is a trap or either it is you are using the wrong equations. Okay, so for question 8, 8-bit linear quantization is used. Determine the largest quantization error. I think this one is not about the not about I know what you want to do. Previously we have another equations, right? Which is 6.02 multiplied by n, right? So you are trying to do, I mean, to get that one. But I think this is not that case. Okay, anyone want to try? Let me call upon another people. Thank you for your answer. Yong Chuan Lim. Yong Chuan Lim. Yong Chuan Lim. Would you mind to share your answer? You may share whenever you're ready. Questions 4B. Yeah, this is the correct equations. One moment, let me grab your answer first. Okay, correct. Okay, good. So thank you for your answer. So it's important for you to identify the correct equations, else you would get the wrong answer lah. Okay, one moment, let me share my screen. Okay, so basically you have a range of -5 volt to 5 volt. I think this one is in the lecture notes as well. So the interval, the largest quantization error, so you get the range lah. So which is -5 to 5, which you, the Vmax is 5. So the number of n is 8. So yeah, just did I did something wrong here? I think this one should be 7, right? 8-bit. Let me calculate. Oh yeah, sorry. It's correct. We are not using this one. We are using this equation. Okay. So 2 multiplied by V max, which is 5, divided by 2 power n, which is 8. So you get this value. And then the largest quantization error can be as much as half the quantization interval. So I did put here, which is chapter 8, page 54. So the largest quantization error would be the interval divided by 2 lah. So the interval is this one, divided by 2, you will get this one. Okay, so thank you for the answer. Okay, so discuss on how additional 2 bits affect the SQN. I think this one is easy lah. As what Sharon already answered, I think I just shared the answer lah. Okay, so for this one, what is additional 2 bits affect the SQN? So consider the worst case of SQN. I think this is in the lecture notes again, yeah, page 54 as well. So 6.02 n dB. So which means every bit you will have the worst case lah. You will have this kind of, I mean this much, this amount of noise, worst case. So and another 2 bits you will get 2 multiplied by 6.02 lah. So hence, additional 2 bits improved by SQNR by 12.04. Because the worst case, which means it would be corrupted by SQNR, which is this amount. But at the same time, when you add in additional 2 bit, you have additional this amount, which can contribute to your audio file. Okay, can you see that? For example, you have 2 bits. You have a 2 bits you have a 2 bits which is contribute to SQNR because the SQNR only half of it, 50%. Another 50% would be useful. So since you have another 2 bits, so which means 2 bits maximum, the corruption noise would be 12.04. But at the same time, when you add in 2 bits, you have the same amount of useful bit added to your audio file. So which means worst to worst case, your adding 2 additional bit will have this amount of uh, dB improve your original audio file. But at the same time, if because this is the worst case only, if usually it is not, I mean usually the SQNR won't up to this worst case lah. Okay, usually won't. So if let's say you did not, I mean not 50% but only 30 maybe and 70%. So which means the additional 2 bit will get additional 70% of this amount. Another 70% of this amount introduced to improve your audio system. Okay, can you understand that one? Any doubts on this one? Which means every bit you would have a maximum quantization noise or the maximum worst case maximum, which is follow the formula 6.02 multiplied by n. But at the same time, since it is only half of the um, uh, bits uh, half of the bits added in, so another half would be beneficial to the audio file. Okay, so maximum the SQNR only corrupt up to 50% of the additional bit. Okay, so at the same, which means when you add in 2 bit, another 2 bit, you improve by this dB, by this amount. Okay, and if let's say the SQNR noise is very low, then you will get a better than this one. Your value of improved bit will be better than this one. Okay, so this is what is meant by the additional 2 bits affect the SQNR. um, a sound card can be described to have 16 bit. Describe the meaning of 16 bit in the specification for audio card. Determine the worst case of SQNR can achieve. Okay, this is something related to this one as well lah, because it's asking for worst case of SQNR and it has 16 bit. So basically, when using this question, I mean using this formula would be 6.02 multiplied by 16. You will get that is a worst case. Okay, maybe someone can share their answer. Moment. Wong Ka Sing. Thank you. You may share whenever you're ready. Either put it in the chat box also can, I think this one. Whenever you're ready. The 16 bit is the number of bit to sample the audio in a second. When the bit per sample is high, the dynamic range becomes wider and have reduced the more quantization noise. And have reduced the more quantization noise. I don't really understand the have reduced the more quantization noise. Or you mean the dynamic, or you mean is the dynamic range wider, so more quantization noise is being reduced, right? Okay, okay. Thank you for the answer. Let me check. But for this one, I believe you need to do some calculations because it asks for determining the worst case of SQ and I can achieve. I think yes, maybe you need a explanation as provided by you. But at the same time, you might need to calculate the worst case, which is using the formula. Okay, six. Why is this one? Why is 60.2 dB? 60.2 dB. How you calculate 60.2 dB? Yeah, yeah, yeah. 10. Why 10? Why not 16? Thank you. Answer from Tan Xin Shen. Because I get the answer same like the Tan Xin Shen. Yeah, that basically is 16. Yes, yes, yes. Okay. So try not to make this kind of mistake lah. It's not worth lah to lose mark because of this. Okay, so let me share my screen. Thank you for answer from both of you. Okay, so a sound card can be described to have a 16-bit. So describe the meaning of 16-bit. So first of all, you need to describe what 16-bit is meant in terms of specification for audio card. And the next question is determine the worst case of SQ and up. Okay. Um, for the questions, not all the question would be um, right in such a way that you have sub question like A, B, C, and D, and not a must. Because yeah, we need to test your understanding in terms of a specific uh, examination or course, but at the same time, we want to know if you can comprehend as well. Okay, especially for those question that testing more on the cognitive level. Cognitive level, which means asking you to justify, asking you to give comment, to compare, to differentiate. All these kind of questions usually they will ask. They will write in paragraph instead of point by point. Okay, because the main purpose is not only just to test your knowledge and correlation of those fundamental knowledge, but also to test the comprehension as well. Okay, so for every bit added to a digital word, you get 6.02 dB of additional dynamic range, worst case of SQNR. So therefore, if a converter or sound can use 8-bit conversion, you can get this value lah. Okay, and 16-bit is this 16-bit of the sound card describe the quantization level. The worst case can be 6.02 multiplied by n, which is this one. Okay, but the answer provided by Gasing is not bad. To me, I think it's better. You can use that one. But nonetheless, remember to add in this one because this part of question asks you to determine the worst case. Okay. Okay, the next question. Discuss the advantage of non-linear quantization in the case of audio signal. I think this one I mean, it's in the lecture notes as well. Why we use non-linear. Okay. Let me get someone. 参虚片. Am I pronouncing your name correct? Are you there? Maybe you can share the answer. This one I think it's okay to share in the chat box. This one is very simple. Even my answer is very short. With linear quantizations, the signal to noise ratio is large for high level but small. Okay, therefore non-linear is used. Wow, this is definitely copy from the lecture notes, is it? Not even modified. As a result, the signal noise can be made constant for both. Yeah, basically you get the point, but nonetheless, um, at least you edit a bit, okay? I'm not sure if you are copy from the lecture notes, but seems like not answering the question, but copy from part of another reference book, sort of. Okay, thank you for your answer. Let me share my screen. Okay, so basically improve dynamic range and SQNR comparing with nonlinear quantization with the same quantization level. Okay, but this explanation is a bit different from what given by 学虚片 okay what given by 虚片 because but the answer is given by her is correct as well. That is because the quantizations I mean for non-linear it meant to be more adaptive. For example, you have, something like this one. If you are a linear, which means all these sampling interval is the same. Okay, but for non-linear, you can get a different, which means you can more adaptive, I would say, more adaptive. Okay, but at the same time, in order to manage non-linear is a bit tedious than linear. Okay, so that is different. I believe this one is included in the lecture notes. I'm not so sure which pages is it, but it is in the lecture notes with a comparison by analog and sampling different interval. Okay, with the rising edge and also the falling edge, the mid rising and also not so remember really. Need to refer back to the lecture notes. Okay, okay. So for this one, yeah, the answer given is correct. And another answer from the other perspective is this one. Okay, improve the dynamic range and also SQNR. As improve the SQNR is what mentioned by Xu Pian, whereby you can more, I mean, the sampling interval can be more adaptive, so that you can be matched to the analog and you don't need to reduce the quantization error. Okay, so question 7, discuss on how the increase of quantization level can affect the resolution of the sound signal. Okay, anyone? Okay, this one maybe you need to share your screen. Question 7. Let me check. Jamie, Lu Jamie, are you there? Maybe you can share your answer. Okay. Um, Tan Xin Shen. Okay, maybe you can share your answer. Whenever you're ready. Do you need more time? I'm not sure with my. It's okay. It's okay. Maybe you just share your answer. Um, it's okay to. I mean, even though it is incorrect, it's okay because the main purpose of tutorial is to um share the answer, discuss the answer, and learn from learn from the questions lah. Not a must you have a correct answer. I don't mind that. Even though, of course, I hope you all did your tutorial first lah, because sometimes you not, I mean, you did not do your tutorial. Somewhat, I would see the tutorial class that, yeah, you can put in here. It's okay. Somewhat, I see the tutorial class as a revision class to me because whatever you learn as fundamental, but it may be appear as a different case in terms of um, question based. So it's best for you all to do the tutorial first. It's okay if you don't know. Okay, I don't need you all to submit it on the spot. Okay, we can discuss. The SQL improve as the number of condensation level increase. Just write in. I just okay. Do you have? I mean, that's all. Is it that's all for your answer? Okay. Okay. No issue. No issue. Let me share my answer. Of course, you have a different answer from mine. You can let me know lah. Okay, because sometimes I did I might be wrong as well. Okay, so if you found that my answer is different from yours and you can justify it, just let me know. Okay, especially the typo. Please let me know. Quantization level is sampling the analog signal. Yeah, this is my answer lah. Okay, let me check again. Answer SQL improve as number of quantization level increase. Quantization number of quantization level increase. SQL increase. Okay. Okay, the question is asking discuss on the increase of quantization level can affect the resolution. Okay, resolution. Okay, first of all, whenever you read the questions, you have to know, I mean, best lah, is to know it is under which section. Okay, if let's say I'm asking something in um chapter 8, but then you miss call related with something in chapter 6, so definitely the whole answer would be wrong or irrelevant. Okay, so for this one, the increase the quantization level can affect the resolution of the sound signal. So look at this one. Okay, we look at these two chart. So you have a sampling, right? So you have a quantization. Okay. Um, quantization is referring the sampling of data in terms of amplitude, which means in your y-axis. But sampling is the one in terms of time domain, which is x-axis. I believe we have this slide in the lecture notes. So sampling is referring the analog signal in the time dimension, and quantization is sampling the analog signal in the amplitude dimension, which is the y-axis. Okay, so yes, you are correct. When you have a better, I mean, highest quantization level, so which means you are more sensitive. Since you are more sensitive, you will reduce the quantization error. Okay, SQNI will be reduced. So quantization level is sampling the analog signal in the amplitude dimensions, which is the y-axis. So the higher the quantization level, the detailed the amplitude in each sampling or in time domain would be able to get, I mean, you would be able to obtain a better, higher sensitivity lah. But in terms of when you have very, very high quantization rate, which means you would have a higher size as well. The file size would be increased because everything would be all the sample will be obtained in a very sensitive manner. Okay, and since this is I mean the value of the y-axis is very small. I mean the gap, the interval is very small, so you would able to reduce SQNR as well. Okay, because SQNR is referring to all the gap that no matter in time domain or frequency, sorry, time domain or the amplitude domain, the SQNR is those gap which is different from the original continuous analog signal. Okay, so thank you for the answer. Yeah, that's all for the tutorial 7. Any question before we end this tutorial? Does resolution of sound signal refer to quality? Yes, yes, you are correct. Because in terms of image processing, resolution is referring to the dots in X and Y, Z, right? So higher resolution, which means you have, HDTV, Ultra HDTV, and etc. So when you change the concept in audio processing, it is referring more or less the same. It is referring to quality as well. But that it is referring to how you sample, I mean, how many sample you get in terms of time domain, which is X and Z, and how many sample you get in terms of amplitude, which is the y-axis. So which means you have a higher resolutions, which means you have a higher quality, and your file size is higher as well. Okay, so this is the correlation between the resolutions. Okay, higher resolution, which means clearer, the voice, the etc. When you have a very lousy earpiece and a very good quality earpiece, you would able to differentiate what is so-called high resolution of audio. Okay, I hope this helped. Yeah, we can proceed to tutorial 8, but before that, maybe you can take 5, and then we proceed to tutorial 8. Feel free to propose to me which chapter you all wish to revise. I think I will start the revision by this by this 12 by this Thursday lah. I will start the revision by this Thursday. And one moment, let me check. So week 14, sorry, this week is week 12. So I will start the revisions um, on this coming Thursday, and we will have our tutorial as usual on Thursday evening, 4:30 to 5:30. And yeah, okay. So if you all did not propose me any topics, so I will select those that I think is worthwhile to uh revise lah. Okay, but it's best for you all to propose to me lah, so that I can revise whatever chapter that you need more clarifications. Okay, so let me continue. Okay, tutorial 8. Tutorial is on the audio compressions perception. Okay, figure 1. Figure 1 shows the Fletcher-Munson's curve, which display the sound pressure level for human ear as a function of frequency. Based on your understanding, explain the relationship between the sound pressure level and sound loudness as level at with frequency. So this one, usually these types of questions would gain a lot of marks lah, because it's asking you to correlate between two items usually lah. Okay, so yeah, maybe for this one it's okay for you to put it in the chat box. It's clearer to me. Let me select someone. Yao Ting Long, are you there? Zerlin Lee, okay. Yi Hang, why area not here? Not yet back from break, is it? Tiong Lei. Is it correct to pronounce as Lei, Liea? Tiong Lei. Tiong Lei Lo. Yeah, would you mind to share your answer for tutorial 8, question 1? Okay. Human auditory systems hear low and high frequency poorly. Alright. When frequency of audio is low, sound pressure increase, loudness increase. Is low, sound pressure increase, loudness increase. When frequency of audio signal between 200 to 20K, sound pressure reduce, loudness reduce. One moment, let me check the graph. 200 to 20, pressure reduce, loudness reduce, sound pressure is low. Okay, I understand what you want to, frequency. Oh, that is all for. Okay, okay. Okay, so that's all for your answer, right? Okay, thank you. Thank you for your answer. This question can be very tricky. Um, Again, depends on the marks given. If the marks given is higher, so you need to explain in details like, okay. But actually, for this graph, a lot of things. I mean, a lot of info is embedded in this graph. Not only uh, the pressure here, which part is more sensitive for human auditory system. It's also imply many current applications in terms of audio. For example, the telephone. Uh, why is the frequency is there for electronics guitar? What is the frequency for the piano and etc. All the instrument is actually propping into a specific frequency in order to fit in. It's impossible for all the instrument to have the. Although we know that at this region, human is much more sensitive to the uh, frequency in this region, but it's not, it is not practical to have all the instrument to occupy at this specific frequency range. For example, you have a soft instrument such as piano, but you have a strong or a very bold instrument such as electronics guitar. So the sound would be the frequency of this from this instrument would be more likely to distribute throughout a different frequency, not only because of the nature of the material, for example, the guitar, the string of this guitar, and etc., but also to have, I mean, we cannot have all the information fall within the same range. For example, you want to highlight red color, you want to highlight blue and green color as well. But when everything is being highlighted, you will get a white color. Okay, so everything must be in a correct portion. For example, you in a concert, you have your lead guitar, uh, you have your piano, you have something else. Okay, it's impossible for all the instruments to occupy the same range of frequency. If like that, what you would hear would be very noisy because too many informations being concentrated in a particular frequency. Okay, so that is why it's important to manage the instrument. No matter, of course, it's not applicable to instrument alone. For all the application, it's impossible for all of it to occupy the same range. But of course, this is also highly correlated to the material itself. For example, when many people talking, but everyone is talking in a different tone. Else, you would hear nothing at all because it is caused by resonance. Okay, so ear is not equally sensitive to all frequency in audible range. So a sound at one frequency may seem louder than the one equal pressure amplitude in a different frequency. So let's say you have a pressure over here. Yeah, this is pressure or what? Let me see. Yeah, sound pressure, which is in dB lah. But for the sound pressure here, if it is in low frequency, you may not be able, you will not able to listen to this audio. But later on, if the frequency is increased until maybe somewhere around here, you will be able to to hear. So that is why if you have a same um, amplitude or same intensity for a particular song maybe, but it's played with different frequency, you would not hear the loudness the same. You may hear, oh, this is actually louder than that one, but in fact, the pressure the sound pressure or sound intensity level is remain unchanged, but increase in terms of frequency. Okay, that is because our ear is not that, uh, fair and square to each and every frequency. We have a very specific frequency range, which whereby as a human is more sensitive to. So that is why we would hear things different. And This graph is sort of heuristic graph, which is more on analysis from a group of big people. I mean, a big group of people. Okay, a big group of people. So your very own auditory system may or may not obey this one. Okay, but mainly the trend is over there. You would be more likely to hear this region more than this region. Okay, it's very you might have a very sensitive auditory system whereby you're able to listen, or I mean wider range, I would say. Okay, wider range, but it's not so possible for you to listen something with very very high frequency like perhaps maybe you are Superman or Superwoman. Okay, so the feature Amundsen's loudness curve indicate the ear average sensitivity to different frequency at various level. So this curve here is actually referring to human ear is actually more sensitive to different level at a different frequency level range. Okay, but of course this graph is not in a fixed interval whereby you have uh, the interval is non-linear lah, I would say, because you see 100, 200, 500, 1000, 2000, 10, 10K and etc. So when you arrange this curve in different, I mean, you arrange this graph in a different interval, you may produce a different line behavior. Okay, you can see different trend. Okay, but when you uh, pull out this Fletcher-Manson curve to a fixed interval. This, I mean, the line on top of it that would be most likely looks like a flat lines, a flat lines. Okay. So for example, looking at the first solid line in the graph, 10 fonts, which is this one, 10 fonts, it can be seen that from approximately 500 Hz to 1.5 Hz as the line is relatively flat on the 10 dB sound pressure level SPL. So this means that to perceive the sound at loudness level of 10 volts, the frequency from 500 Hz to 1.5 kilohertz must be 10 dB SPL. If less than 10 dB SPL, so it's not able to listen. If, for example, maybe 5 or 9, you will not unlikely to listen. The line dips more stably at 5K Hz. Hence, it perceives the sound at 10 volts and the SPL only has to be 6 dB, which means this curve is go down again at around 6 dB, which means if uh, you can see the y-axis curve as the energy. For example, you need how many energy so that your ear can listen whatever message it is. So at this point, at this frequency range, you may need around 10 dB. But at this frequency range, you only need around 6 dB. So this is the difference over there. So which means if you play something else at this range, it will require lesser energy to bring out the message to any people. Okay, so that is why our phone call and etc., especially phone call, the old glory time, those phone call, even during now, we are more likely to fall within this frequency. Uh, the phone will automatically process your sound and push it to this frequency so that it's easier for us to listen with with a lesser energy required. If let's say any voice or any tone or any audio is pushed towards this, is fall within this region, so it's very hardly for the people at the another end to listen because it's require more energy. So what you need to do is maybe you need to increase the volume. Okay, but let's say it's very, very soft. It's unlikely for you to listen, although you are with the maximum volume. Okay, so that is the difference here. I mean, that is the main purpose of this lah. Because sometimes to somewhat the answer given by Tiong Lei is not so accurate, is that this is not a linear graph, whereby you may not define a trend at this end and another trend at this end. because if this is a linear graph increase for example maybe exponent graph, then it's fine because you have a same behavior when you increase in terms of y domain or x domain. But for this graph, it has a different domain. For example, at this point, you may have a reduce in pressure. I mean, you need more effort or more energy or more pressure in order to listen to a specific frequency. But this train keep on reduce or improving until here and decreasing until here, and then improve again and decrease again. So that is the reason why if this is a such as an exponential graph, so you can just pick up or just label uh, the behavior from two extreme is okay, because I mean all the relationship throughout these two extreme would be somewhere around these two extreme, which means when you're approaching to left, you have a maybe lower in intensity. When you are approaching to y or the right extreme, you might have a higher intensity, something like that. But for this curve, it is non-linear, whereby you may need to jot down the specifications. I mean, at a specific range, what happened, and then another range, what happened. Okay. So notice how the low frequency curve line flattened as the overall loudness increased. So basically, this is very high, this is very low. And from here, of course, the graph, should be extended until somewhere around here. Lah. Okay, but nonetheless, the gap between this point until here is very small, and this point until here is larger. Okay, so that is why when you have, of course, this is not so visible using this range, using this x-axis range. If you arrange it in a fixed interval, you might see that the line, I mean the top line, the first line here, which is 220 fonts, is more or less looks like a flattened out. But of course, the flatten out is in conjunction with those lines here, okay. So that is why it's actually flattened out, which means everything listen the same. You need more energy for no matter what, because it is very high in fonts. So no matter what frequency it is, it sounds the same. Okay, no matter you are in this range or in this range, you still require a lot of different, I mean, a lot of energy in order for you for once to listen to that sound. Okay, the low frequency line flattened out because the higher sound pressure level in the ear is more sensitive to low frequency. Or also, notice how the ear is less sensitive to the frequency above 6000 K, which is somewhere around here, because has I mean, increase in terms of the graph. This explains why soft music seems to be less rich and full than louder music. The louder the music is, the more we perceive at the low frequency, and thus it's become more full and rich. This is why many stereo systems have a loudness switch, which boosts the low and high frequency of the sound. Okay, this is another example, whereby actually you increase the loudness of the audio, or you actually feel like, oh, this music is I mean, full and rich, which means the details inside the music is very clear to you. But of course, this one is not referring to those with high pitch, but you just increase the volume alone. You will feel that everything is much more clearer to you, because all those frequency information which fall within this frequency, let's say you have 10 fonts only, sorry, um, 10 dB only. So you can only listen to this range, and those information or the audio file or the signal is fall within here is less likely to perceive by you. So you might be able to hear this volume or this signal, but it's unlikely to be very clear. But let's say if you boost to 40, so everything, I mean, all the information under this range would be very clear to you. So that is why you feel like, oh, when you increase the volume, basically you will feel like um, the music is much more clearer, like HD, something like that. Okay, this is one of the perception which obey the Fletcher-Bunsen curve lah. Okay, so this is actually a much more thing. I mean, we can explain more lah, in terms of different this curve. This is a very interesting curve and important for you to know. I mean, at least to know how to see the relationship there. Okay, because this is the only I think the only graph that we have in audio processing. Okay, it's good for you to know the behavior. Okay, how is the low frequency, high frequency affect the uh, perceptions of the audio? How is the sound pressure level affect the perceptions, and why are some of the multimedia application is code specifically under this region, especially this one, 500 to 5 kilo is where the phone operate. Usually we will I mean push all the frequency into this region. That is why the call from different people maybe sound very I mean uh, it's likely to be appear like a same voice like the robot voice because they want to push the frequency, I mean all the input analog sound to this range. That is why sometimes, especially when you hear from the FM, so you would hear like the call up voice is more or less the same, no matter it's male or female, old or young. It's more or less the same. That is why that is because all the frequencies being pushed to this range for easier, I mean, for us to listen, especially for secondary uh, replay. People called up to the FM radio, and FM radio replay the video, I mean, the audio call to the public live. So if you did not push to this region, perhaps you might have, I mean, cannot listen, it's not clear, and a lot of different issue there. Okay. And of course, some of the instrument, for example, electronics instrument especially, they will typically select a specific frequency for you to, I mean, to play the to play the instrument. For example, electronics guitar is more likely to be at 5K. Okay, so that is why the electronic guitar is usually used as a lead guitar lah. It's very rare to use the electronic guitar as a background instrument. Okay, maybe background instrument would be something softer lah. Okay, yeah, something like that. Okay, so now it's 5:55. I think we can stop here, and then we will continue the rest of it in on this Tuesday. Okay, any question before we stop? On the count of three, two, one. Okay. If you have any questions, let me know. You may email me, and I will confirm again with Chie that this Thursday class is it online or a hybrid mode. And nonetheless, do propose to me or propose to Chie that do you have any subject or any chapter that you want to revise? So we will start the revision on this Thursday lecture class. Okay, and what else? I will try to revise. I mean, release the assignment by tomorrow or Tuesday, and then you all check and reply me if any lah. If don't have any things, I mean, to revise, so you don't need to reply me. You can reply me by Friday or this week lah. Because Monday I need to key in already. And what else? No, I think that's all. Okay. Yeah, thank you for your attendance, and that's all for today. Thank you, and bye bye. Please take care of yourself because soon to sit for physical exam.